Now, as we have the Simulink model, which is fully tested, including static analysis, structural coverage, coverage of design ranges, and validation reports. See how it is done. Static analysis is done, then the complete testing, the measurements are done, decision MCDC coverage, coverage of design ranges, and then the verification report is provided, in which you can really see what's going on. The work products are all stored in the correct folders. I also see that we are working in the work folder. We should actually develop a TMS folder, TMS for the unit, and move all of these folders to the TMS. All right, so now we're all set. And the next step would be now to work with the Stateflow. So this is the Simulink part. Let's develop it as a flowchart. For this, we will need a variant subsystem. I develop it like this. You can do it by hand if you want. And in that variant subsystem, I now will just copy this TMS. We'll also break the library and call that block a TMS SF. Switch to that. So now if I go to this one, I'm in the variant and I want to switch to TMS SF as a test object. Okay, it's running. This is exactly now where we will start. So basically, we still have a subsystem which we will make a library. As we are working here, we will disable the library. It should be activated. And we can reuse a lot of stuff here. But the first thing that we will reuse will be the parameters. There's interface, the requirements ID, and all of that will be now designed in Stateflow. So I will just delete it. Now we open this SF library chart. And with this chart, we will connect the inputs like this. On threshold. Off threshold. And the switch. Looks okay to me. See, I spent pretty much time moving these ports. You can also do it by using this feature. It will be done automatically. We now can also associate this requirement with this block. and div ready are fine, but data and data1 are not the correct names. I will rename it to on threshold. Not quite correct. And off. Threshold. We are done on this. And now if we go inside, we'll see that it is all empty. Also, it is MATLAB action language selected here. Nevertheless, we can start implementing our requirement. Let's open the requirement. So the first is if, then, else if, then, else. So basically, we want to use this two objects like this, and you can connect those. All right, but it is a better way to use the patterns. And we have this couple of else's. I do not even fill it out here. I just do it like this. And so now I have the complete ready to use pattern. And it says here, if div and ready, then switch on. So I just copy it completely. This is the semi-formal notation. And we know that in these square brackets, we have our condition. So I will fill it here. This is the condition. True is probably not the good naming here. True, like this. How about this? There is some syntax error there. Ah, yes, and. How about now? Yeah. So, and if so, then the switch on should go on. Shall I use on? I will just use true. Like this. Then the other one, else if the condition 2, we know and is this and true is this true. You see this object are actually placed in the wrong manner, so I can move it to make it readable. How about this? Yeah, it's better. And then switch on should be off. Off is false. Doesn't look pretty nice yet. Probably need to move it again a little bit. And otherwise, switch on shall not be changed. So basically, for me, it's kind of nothing. Do nothing. We're pretty much done with that implementation of the requirement. I now want to run the static checker. Simulink is okay, but what about Stateflow? Run and fix. It finds a couple of problems. It actually changes a couple of settings, opens the Model Explorer and says there are troubles here. So there might be a chance that the interfaces are not quite correct. So let's see, this is the input, same as Simulink for the data type. Minimum maximum values can be defined, but we do not need to define it here. For the ready, input type is same as Simulink. Also, everything is inherited. On threshold, apply. Again here, same as Simulink. And inheritance, we probably do not need to introduce min and max values here, but I leave it for now. Apply. And here also same as Simulink. So let's run again. The Stateflow checks. It says on threshold is not known. Is it so? Modeling. Model Explorer. On threshold is input. On threshold. Okay, the name is wrong. Threshold. Thank you. Threshold. So how about now? Try to update. Oh, it's actually compiling. So basically, the semantics is kind of okay. So let me run and fix it again. And now I need to check what it is actually, what it doesn't like. There are a couple of settings that we still need to look at. So Stateflow port names for, oh, the signals are unnamed. Okay. If I get out here, this is correct. So we need to give these names for the on threshold and for the off threshold. So all of them need to be named. But now it's good. So what is here? It says check explicit interface definition for diff. The min-max values are not defined. Okay, it did it, but it did define it for switch off for the ready, but not for diff. Okay, then let's define 128 and 127. How about now? Yes. For the state transition, there is something to follow. Stateflow transitions are not drawn straight. Um, so there are some troubles with the transitions. They are not quite straight. So if they are not straight, right, it will be seen and you can modify it automatically. Sometimes this path is not quite. Now it is better. Also move it a little bit over here. So stateflow chart properties, run, modify. Okay. The last one is also fixed. So let's run it. Almost everything is fine. There is the problem with transition labels. It seems like they can be fixed. They were fixed. And now we only need to save the model and the library. So let's save that model, push. And as we already have some test cases, let's see how they run. Oh, there is trouble already. The other ones are fine. So we can run actually everything to see what's going on. Static analysis is not quite ready. And one of the test cases failed also. And we did not achieve the MCDC coverage, it says. Let's look at this one after another for the static analysis. Okay, for this one, we need just to close one of the windows. Improve the zoom factor. For this one, model reference, extra modified. And then check explicit initialization, run, modify, run. It is done now for Simulink. And for Stateflow. You do that static analysis now because it's much easier to do it now than later. Okay. An embedded coder. Okay. How does it run here now? Simulink library is disabled is the only problem. Okay. Push. Static analysis is okay. But there are some troubles. So compared to Simulink, it does not work the same way. Let's discuss this. So first of all, I'm interested in why the behavior is different. So basically, this one condition is not quite covered for the MCDC coverage. It says full decision coverage, condition ready is true was never false. As you see, this is exactly the problem that we see in our case here, because we set the ready to 0 and then to 1 to see that it actually influences the output, but it doesn't. So both MCDC coverage and the requirements-based test demonstrate that the behavior of this model is not quite like we expect. So we need to debug into it. Let's see. So I will start a debugger, and we want to go to this step 0.060. 06, continue. And now we see that the value is true, right? The value of switch, if you go over here, switch on is 1. And now if we step to the next spot, it is still 1. And if you look the way it runs over here, it actually does not prove whether the ready flag is false. Now it is basically keeping this signal even if that ready flag is false. But in the situation where the ready flag is off, we should set the signal to off. How can we improve it? I will try to set this ready flag to off. So basically, if we look at this model, we see that only if the ready flag is true, we can set the on threshold, the def. Based on def, we can set the switch on to true. This is the only true path. And if this is the false path, then we should not prove on ready is true or not, but we should prove on ready false, and not with and but with or. Let me try this. I will set this one to false and this one to or. How about this? Now it looks that it works well. How about the rest? Nice. So you also see that the animation is helpful. And with the animation, you can combine it with the debugging. You can really step by step check what's going on in your system. It's a little unexpected result over here, but I think it works well. I stop debugging, and now I activate all of the reporting again and run the verification. So the library is disabled. That's why I have this report. But now I get my MCDC coverage. So the only thing that I need to do now is to stop the coverage reporting and connect the link again. Let's make it 100%. Okay. Save it and run it again. All right. Now we are done with the development of that Stateflow chart. And we also created the libraries, the test harness. And in the reporting area, we have our coverage report. With full coverage, decision, condition, and MCDC, SMA report with full coverage, verification report, and verification overview. In the verification report, we can also see the complete set of our testing, and we can navigate in the EverPlot. And now, based on our assumption here, we can again look at the requirement. And we see that this is actually not quite correct requirement. So we need to change it to or, and here false. So I hope you now also see how semi-formal notation helps us to describe the requirements in natural language. But the mathematical notation or modeling is providing an extra very important insight into the requirements. And now we have the complete workflow where we have the requirement defined, then we implemented the requirement in the model, and we found some problems in the requirements and needed to actually change it. But then we also tested the requirements, and that provided an extra insight into the model. We found problems in that model. So basically some kind of understanding was correct, but the implementation was not quite correct. And we've seen that with this implementation, we actually found another problem in the requirement. That is this part of the requirement. Very interesting. And now we have completed the verification. We know that the model is fine, both statically and dynamically, and the requirements are correct, and the requirements are also fully in compliance with the model and with the testing. We also have a requirements matrix in our verification report where the requirement is specified and the test cases which test this requirement are also mentioned.